For this fourth part of the video, I'm going to work the 4 problems that Mr. Spelling skipped because he worked these problems with his students in class. So the first one that was skipped was question number 1, which was 7, the square root of 24. Okay, first I'm going to break down 24 into 4 times 6. 6 only breaks down 2 times 3, so it's not a perfect square. So I'm going to stop my factor tree here. And then when I take the square root of 4, that gives me 2. So I have 7 times 2 times the square root of 6, which simplifies down to 14, the square root of 6. I cannot go any farther than that. The next problem that wasn't in the other reviews is question number 6. The first thing I noticed about this problem is I have 2 square roots of 45, so I'm going to just go ahead and add them together and make it a little bit more simple. And then I'm going to do my factor trees to simplify each of those square roots. And then the square root of 16 is 4. And the square root of 9 is 3. So that leaves me with negative 12 the root 2 plus 9 root 5. And I cannot go any farther since root 2 and root 5 are not like terms. Now question number 15. To simplify this fraction, the first thing I'm going to do is rewrite it as 1b division underneath the radical. And I'm going to simplify the fraction 5 over 25 as 1 over 5 underneath the square root. Then I'm going to break up my square root again. So I have the square root of 1 over the square root of 5, which becomes 1 the square root of 5. Then I'm going to rationalize the denominator by multiplying the top and bottom by root 5. Multiplying straight across, I get root 5 over 5. That would be my simplified answer. And the last one Mr. Spelling didn't work out was question number 23. Remember, when solving these radicals equations, first thing you have to do is get the radical in by itself. So since I am subtracting 6 from the radical, I need to add 6 to each side of my problem. That'll give me radical of n plus 1 on the side of the equal sign by itself. Once I have the radical all by itself, then I square each side of the problem. That leaves me with n plus 1 is equal to 100. Then subtracting 1 from each side, I get n is equal to 99. Always remember to get in the habit of checking your answers on these radical equations. So plugging in 99 in place of n, let's see, does that really equal 4? Since 10 minus 6 is 4, then yes, it does check out.